It is, let's see, November 5th. We've got a pretty big crowd here today. I know Andrea said that she is not able to make it today. She's got something propped up in Barrett's late. So we'll just go ahead and get rolling. So screen share. All right. So it was a mildly busy week for me, I guess. I've got some new stuff that came in for the lab, including 2 new POSIX anchors for Addison, the Micro Jumpstart, which is a big battery bank, which I intend for this to be used with the LiDAR and kind of everything else. It's got a nice little 12-volt port that you can tap into and lasts forever. It has a pretty good amp rating, so that should be great. I got a micro HDMI cable adapter for the FLIR camera, so we can put that up on the TV. I tested that out. That works. I did notice that the power was a little bit odd on the bench cable, which I already let Benja know about. But we should track that down and see if it needs to be. I don't know. I'm a little afraid that one of the wires is broken in there, and that if you kind of bend it one way, it breaks the connection. If you bend it back, we don't want that power coming on and off on that camera. That could definitely damage it pretty quickly. So we should get to the bottom of that soon before we use the camera. And then 2 additional batteries for the Hero 9 and a little case to charge them. Johanna, I don't know if that's of use to you when you travel or not, but they're tiny. Even if you don't take the whole thing, you know, you could take 1 extra battery maybe, and then that would be a benefit. I always fear running out of battery power on field collections. I also got an email from somebody from Esri about getting a new key generated for our N-frame shear license, which we have not really used. I kind of got this set up in, I think, August, and I've barely touched it, but I hope to come back to that. But it may be that with the handover of the license from, I guess Esri bought N-frames, so I guess from N-frames to Esri. Maybe it changed. Anyway, I forwarded this to Seth Peary on campus. He said he'd look into it and see. I did the last one on my own, but this time they're asking for a signature of the university administration and an official stamp on the agreement, which I do not have. So we'll have to see what that is. Taryn, have you heard much about N-frame Sure?
Yes, I know a little bit about it, but I can't say it on here.
Okay, fair enough. So this is something for the for Maverick. So the computer that's hooked up to the 3D printer. I finally got around to reinstalling it. It used to be in there, but when we wiped Maverick a year or so ago, I never got back on. But SketchUp Make 2017 is on there with an export STL. So if you've got quick things that you need to kind of mock up and print, like parts or brackets or things like that, then SketchUp is kind of a nice utility for that. It can do more than that for sure. But I also added a little software section to the 3D printing wiki page to keep track of things like the install file for Make, which they've kind of changed the licensing around a little bit. So I happen to still have the installer from the last time I installed it, but they don't put that out on the web anymore. You've got I don't know, there's like a web version and there's some other stuff. So anyway, we got a copy of that. Probably the biggest thing I worked on last week was getting all of the code that used to be a script for doing the PPK, RTK image tagging to the GoPro images is now, it's all of that stuff is now in NeilPy and uploaded. And then that makes it a single function call to do the whole job. So you'd import NeilPy, just kind of bare bones. You'd import NeilPy, you'd point it to the either RTK or PPK file. So this is either going to be an LLH if you've managed to RTK it, or it's going to be a POS file, position file, if you're PPKing it, which is the same data. There's just some different header information. It's essentially just the precise position of the GPS, which images you want to tag, and then what you want to write it out to. So this gets written out to a CSV file. It doesn't overwrite the geodata that's in the tags themselves, but it produces little CSV that you can then import into Pix4D when you're running it. It's got some parameters here. It's got a time delta, which is just sort of like how far off the time is from the GPS time. So we talked about this last time, that the GPS time on a GoPro will be floored. So it will always be rounded down. So you kind of have to figure out where that goes. I don't think it really should be much higher than 0.25. So that's a bit of a mystery. But I'll talk about this 0.6 here in a second. You can specify the horizontal and vertical accuracy. Here I've specified them at 2.5 meters, which is way too high. I was getting some odd results with Pix4D, and I wanted to kind of crank that up a little bit when I did this, which shouldn't necessarily hurt anything. But those numbers should be, I found something that suggested that they probably should be at like the 4 or 5 centimeter as a true measure of their accuracy. They're all pretty much fixes, I think, in this case. And I don't know what the other one was, like 1.5 or something like that. It was a float. What I want to do, and what I had done, but I kind of took out again, was making this responsive to whatever the quality rating is on the tag itself. So whether it's a fix or a float or whatever. The GPS height is how far the antenna is above the camera. So it's always going to be a little bit above, at least the way we've got it on our rig. So there's that. You can set the camera pitch. Here I've set it to 0 because this is the one that we had done with the facades. The camera was actually pointed forward. And then there's a tag here that says GoPro equals true. And basically what that does is that applies this sort of 18-second offset, because the GPS time on a GoPro image is actually UTC time. So that's definitely 18 seconds off. So it just factors that in there, which is fine. And then I also added a couple of other little things in here. I think maybe the only one that I haven't mentioned is the GPS time offset is set to 18. Theoretically, that will increment as we go on in our lives. So I don't know the next time that's set to increment, but at some point it will go to 19. And now we can just, I don't know, maybe that's just a reminder to me that we can go back and fix that if it changes, but I don't know.
Real quick, Dr. Pingle, I don't really understand the 18 thing.
Yeah. So so normal time that we're all kind of familiar with is UTC time. So that's just like you pull up the time on your phone or whatever. Everything's tuned to sort of a global clock. But GPS satellites were initially timed to that, but are now different. So leap seconds need to be added to UTC time, but they are not added to GPS time. So, or subtracted, or I forget which direction that goes. But they've started to diverge. So GPS time and UTC time are no longer exactly the same, and they are 18 seconds off at this point.
Okay, so the GoPro GPS time is about 18 seconds off, or the...
So it looks like what happens is that, when GoPro writes the software for their camera, they get the GPS time, but then they subtract 18 seconds to convert it to UTC time. So the tag on there that says GPS time is actually in UTC time.
Okay.
Already had those 18 seconds subtracted out. But because we are comparing this to an actual GPS, where that does not happen, we need to make those both in the same. Either they both need to be in UTC or they both need to be in GPS to do that.
Got it. Okay.
So it's just an alignment.
Yeah.
I also upgraded the routine that tags the photos. So this was an attempt to sort of resolve the time delta issue. But what I had been doing was, so if you take an image every half second with the GoPro, you're going to get 2 images with the same exact time, because it's going to round it down. So if it's like, noon noon and 0 seconds, it'll be noon and 0 seconds. If it's noon and 0.5 seconds, it'll be 0 seconds. If it's noon and 0.999 seconds, it'll be rounded down to noon. So you get this sort of separation, you know, within 1 second, you don't really know where it is in that zone. I had been sort of looking at that and then retagging the time. So if there were 2, I would just assume the first one was at 0 and then the second one was at ½ second. And that would make the whole shift potentially off by up to ½ second, because the 0 could really be at 0.5 and the 0.5 could really be at 0.9999. So there'd be a ½ second of wobble. And now I'm pegging it at 0.25. So at least there's no bias. It should be more accurate in general. It shouldn't be more than a ¼ second off in either direction, but it could be in either direction. Whereas before it could be up to a ½ second off, but only in one direction. So hopefully this is better. We're still very much testing this out. I did come up with a nice way of estimating the time delta, which is if you load the images in Pix4D and you've got a GCP in an image, so this is one of the Frisbees from the Long Park data, what you should be able to do is sort of like click on this image and it should basically be aligned with the GCP. Otherwise, like if it's up here, if the image with the GCP that's kind of like right at your feet is over here, then you know you're off by kind of however many dots there are. So if it was here, then you'd be off by a ½ second, a whole second. And if you know how fast you're walking, which is usually in the ballpark of about 1 meter per second, then you can start sort of scooting those forward and backwards without having to rerun everything. All you would have to rerun is PPK image, but you don't have to even do like a full Pix4D run. You should be able to just like load it up, eyeball it, see how it goes. And hopefully it's within a second every time. I did a bit of a test to see how the time delta plays out. So one of the neat things is when you run a Pix4D thing, it'll output a lot of little diagnostic files, but this is one of them, calibrated external camera parameters. And it'll tell you where the image was, and then it'll tell you where the image ended up. And you can get these in projected coordinates, and there's a bunch of really neat stuff. But essentially what I did was run Pix4D with it pretty close, pulled up the coordinates of where it thought it was after tuning it to the GCPs that we had. So we know that the aligned coordinates are probably right. And then shifted that time delta and reinterpolated it. This doesn't require running Pix4D, it just requires rerunning the PPK images function. And so you can see it kind of bottom out with the time delta at -0.6. The mean error of the whole system reaches a minimum at that point. Does that make sense, Johanna? You're the one that's most likely to be interacting with this, I think.
I think I'll have to stare at this a little bit more.
I think bottom line is probably -0.6 is a good place to start. And I'm really curious to find out after we do this a few times how stable that -0.6 seconds is. It really shouldn't wander much, but it may wander a little. I don't know.
Okay.
The way that I understand, my best understanding of how the GoPro is actually working is when you set it on a time, on a time delay, like what do you call it, like every ½ second or something. It's using its internal clock to trigger the shutter, but the internal clock is not necessarily aligned at all with the GPS time. So that would still account for a little bit of shift. I still don't think that shift should be more than a ¼ second. So I don't know why. I don't know, maybe there's a lag. I guess there could be a lag in somewhere in the system. I don't know. Anyway, we'll just have to see how it works out. This is the RTK tagging for Wallace Hall that we did last week. Benjamin and Barrett and I went out and did this. The results look great. So if this were just regular GPS tracks, these would be all over the place, but this is pretty nicely fixed. I just grabbed this out of the middle of the run. You can see the place where we actually, there's a tree right here. We ducked in front of that tree to like get it, and it showed up really nice. I think this is a really great representation of where we were. And the end result is actually pretty nice. So I rendered a little video out. So this is the facade of Wallace from the Pix4D run embedded on the LiDAR data. And the alignment is actually really good. I'm going to pause it right here. The alignment is super good on the XY. It's off on the vertical, which we've noticed before. I'm not totally sure where that is coming from. I assume it's some kind of a vertical datum issue, but you can see it where I want to see that at the bottom. So as we duck underneath the ground surface, the LiDAR ground surface. Oh, sorry. So look at the bottom of the image right here. We're kind of at eye level with the LiDAR ground, and there. Oh, I should have had more at the end. You can just sort of see it. So this is the LiDAR ground surface right here. And then this is the photogrammetric ground surface. So I measured that at like 1.4 meters. Which is pretty big. It has to be a datum issue. But it still looks really great. This is sort of a static render. The bricks come in really nice. Like you can see, you know, the accent bricks or whatever they're called. Yeah, overall a really nice thing, and no MTPs required. It just all came together, you know, ran very quickly and looks very good. This is news for Gungeon. I did get the touchscreen installed and working. It just took a second, so I just did it. And then I also fixed the MATLAB code that I needed to draw that yellow line that was missing. There was a piece of MATLAB that broke in the several years since I've run this study. So I went back and changed that just a little bit, and then it works. So that is ready to go. I'd really like to get some volunteers this coming week to run participants through this study. It's really just a training exercise for Gungeon so we can get used to running a map study. We're not going to keep the data. We're not going to do anything with it. It's just a practice. I also got things prepped for using the Velodyne POC for some scans around campus. So Barrett and Addison were with me to get that started. This is a nice. I used my the camera on my phone to record this. This is actually invisible if you're looking at it with your naked eye, but if you use your phone, you can totally see it. It's great. I don't know. I always still love that. But anyway, I got the LiDAR view installed on Goose, and there's a new version of LiDAR view. It seems to be up to version 4.2, and it's kind of a chaotic bit where they talk about all this stuff, but I retracked down the directions, so those are here, and they're also linked on the Velodyne LiDAR wiki for actually running SLAM with the LiDAR view. This is, I ran it on that data that I collected just with default settings. So you can see how awful the reconstruction is here. This is the first, this is the second floor Wallace, total garbage. This is the equivalent of having not good default settings in Pix4D or something. Like it totally didn't turn out. We'll have to figure out the settings, and I'm confident we'll be able to get it to snap together. Not this one per se, but you guys will probably like gather some new data, and we'll do it that way. I have high hopes that we'll have something next week, at least as a start. And then this was just a static render, which I really like. It's nice for everybody to sort of see what these instruments, what the output looks like. It has this characteristic stripy kind of look to it as it's rotating that laser around the whole room. It spins on a particular axis. And so it gets these sort of concentric circles of its environment as it goes. While I was looking at LiDAR view, I noticed that they support a couple new LiDARs. I had to laugh at this one. I hadn't heard of this one. I'd heard that the Velodyne lasers had been sort of knocked off, but they definitely have. So that the Hesai Pandar 128 seems like a great little LiDAR system, but also surely a direct ripoff of the Feldenite stuff, which is kind of sad. I'm also looking at Beth Pryor, who's a PhD student in the GEA program, is trying to use SMRF and some other stuff to do LiDAR classification of their helicopter sourced LiDAR data. And she's trying to automate it. And she had some questions, so I've been working with her a little bit on coming up with some easy examples of how to do things, LiDAR processing in Python with LASPy. So LASPy version 2 came out pretty recently. It's got some nice syntax. I still don't love it. I still don't love PDAL. I'm going to be sad to see LASTools go. And lots of operations are just going to be a little bit harder without LASTools, unfortunately. So last week I had a lot of goals. Some of those kind of came across just fine. I didn't train Gungeon to run the participants on the old study, but we've got it set up to gather data now, so that's a step in the right direction. We didn't get a new LiDAR scan, but we got the stuff out and it's working and it's ready to go, so we're set up for success there this coming week. I was hoping to get a full exterior model of Wallace, a photogrammetric model, but I think maybe Barrett and Andrea and Addison are leading the charge on that next week. I didn't gather any data from the LiveVox. I thought about staying up late to do that last night, but I didn't. And I didn't collect any RINEX data with the Google GPS logger, but Karen, you said you at least downloaded it. Did you find some time to do it this week?
Download the GPS logger or a different one?
Which, I guess it's like GNSS logger, but.
No, I haven't done it, but I'm actually going to go back to Richmond this weekend and keep working on sort of the scan project I'm doing there. And I'm doing the floor, so I'm going to try and take a couple points and see if that helps the reconstruction.
Okay, cool. Next week, in addition to kind of finishing out some of those ones that I didn't get to this week, I want to get the lab rover running. I spent a few minutes on it this week. It powers on. It probably hadn't been powered on in maybe many months. I don't know. Maybe May or June was the last time it had been powered on. So it took a long time for it to get a GPS fix, but eventually it did. I couldn't arm it though, and I'm not sure why. So I'm going to take it home this weekend and see if I can diagnose that. Andrea and I are going to work this afternoon on getting the Hexoon drone a ways forward. So if people are around for that, you're welcome to join in. And then I know I owe Gungeon and Colleen some editing on the writing. So take some time for that. That's it for me. Anybody have time constraints today that we need to watch out for? All right. But in that case, we'll just kind of keep going around the table here.
Dr. Bingo, were you saying that LASTools is being shut down?
The guy that makes it died.
Oh no.
It's kind of a one-man show. So I don't know what's going to happen to it. Unfortunately, our license expired, and so we can't renew it. Some of the stuff is Beth and I talked about this, and it's worth knowing. Some of those tools, I mean, all of the tools run if you just download them, and even if they're unlicensed. Some of them will do certain things like introduce little errors or stripes or something to kind of encourage you to do that. But a small set of the tools is actually licensed for free use. So merging files and converting files, a lot of that stuff is still available, and so I'm probably gonna keep using those tools for as long as I can. After spending a lot of time on even something simple like merging LiDAR files, you know, many programs can do this. So ARC can do it. Cloud Compare can do it. I've got a little bit of code that can do it in Python, just with LASPy. PDAL can do it. But it's all significantly, you're probably going to spend 5 times longer getting it to do it than you would with Labs tools. So that's the part that I'm going to miss.
Yeah. Okay. So starting my presentation over here. So this week was kind of a bit of a slow week because I had like big submissions in the courses. So mostly stayed inside and didn't get the chance to go out and collect some data that I was supposed to do, but couldn't manage time for that. So this was the thing that I did with the Google Earth Engine. I've been telling it for like 2-3 weeks now, but finally got it. So I downloaded some thermal image from Google Earth Engine, and I used the band 10 from Landsat 8. So this was the code I used. So technically, I was struggling a bit because like my plan was to like download to select the image for my area and then like convert it into array and then make some calculation because make some calculation like in the remote sensing classes there was this equation like to convert the spectral radiance to brightness temperature and then convert it into Celsius. So I was trying that, but somehow I couldn't figure that out. But later I figured out like how to do that, like how to convert the image into array and then make calculations and then come back. But I was a bit struggling in that. But I found another article which used a very simple solution, and I tried that and it worked. Question mark whether it worked or not.
Yeah, so one of the things, even looking at this today, so I got a chance to see this yesterday.
Yeah.
Isn't it curious that like the overall pattern changes so much? Like I can imagine the temperatures changing, but wouldn't you think that the warm places would still be warm and the cold places would still be
My
cold?
only possible guess would be like aspect and like the direction of this like slopes, and that the sun angle hits more direct on like different parts of the mountains.
That's a good thought.
But it is such a big change. I was looking at like there's one spot kind of in the middle that stays constantly yellow, and that's like the only spot that.
Yeah, that's downtown. So
Okay.
that makes sense.
Okay.
But why would like that one be warm and then that one be like? Doesn't that seem weird?
One of the reasons that could be like I have taken like big durations and took the mean temperature out of them. So I can just try to reduce the duration, like maybe month-wise, and then see the changes.
But you would often, I guess I would suppose that a longer average would make that even more stable, not less stable. Like if you're averaging over a 6-month period, shouldn't all of the individual differences, like you could imagine some, I don't know. But that would have better look into it though.
Yeah. So that's the thing we were like Dr. Mingan and I was also discussing. Like we should validate. Like I need to validate this data, like whether the temperature value I'm getting in here, whether they are correct or not. Maybe talk with Dr. Rijal or Dr. Yang Chao and also like validate with data from National Weather Service whether the mean temperature that I'm getting, whether that's correct or not. So I need to validate that. And also you can see in here, like there are some missing data in here. So Dr. Mingan showed me how to interpolate it and like fix the issue before flipping it. So yeah, but it was a good task, and it was also a very good opportunity to like extensively use Google Earth Engine and make some calculations and download the data.
Yeah.
And I guess I'm planning to like make this as a Python program so that I can just like just enter the filter dates and parameters and like, it will just download it.
Yeah, I love the fact that this is a Python-based Jupyter notebook and still using Google Earth Engine.
Yes.
This is fantastic.
Yeah, and also like there are like good syntaxes in Google Earth Engine that makes you like that allows you to like make some mathematical operations in there. So then you don't need to like convert it into pandas data frame or NumPy arrays to do that. You can just use that syntax. So I need to go over that as well. Like those syntaxes will be easier to operate on this rasters.
Have you talked to? I don't want to get too much into the details, but if you haven't talked to Theo in a while about this, make sure that you do that.
Okay.
Maybe within the next couple of days would be great to email him and be like, I've been doing this. Can we just talk a little now that you've got some experience and he's done it? I think you guys will have a more fruitful conversation now that you've both got experience.
Sure. I'll do that. Okay, yeah, so this is the data set I used from Lancet 8. So if you want, any of you want to look at it, you can look at the problem is like using Python for Google Earth Engine, like there are like very less examples in the web because most of the people are using Java. So it's kind of like read through the Java code, like understand what they're doing and then convert it into Python. And most of like many functions in Java are not working, like those are not existing in Python. So it's kind of like a messy thing, but it's good to like go through the codes and understand it. Like it was a good process. And this is the date range I use. This is something I found online, which tells the temperature variations in Blacksburg. So I kind of use this date. So maybe I'll just experiment with like smaller duration, maybe month-wise, and see how that looks like. Because now I have the code, I just need to like change the date and like download it and clip it and make a GIF out of it. So now it's my 1 hour task now instead of a full day task. So I guess I'll just try that out. Okay, so the next thing is my exploration for like FLIR Duo Pro R camera thermal reconstruction. I posted it.
Yeah.
And also I emailed it, but didn't get any answer on the email. But like someone from the Pix4D was asking my files. I sent him, but I haven't received the responses yet. So maybe I can see that he's a community manager over here. So I'm expecting at least something.
Okay.
So let's see how that turns out.
Okay.
And I needed to get my IRB certification for the study I'm planning to conduct in the next semester. So this is it. So I got the certification.
Yeah, nice.
So yeah, so one thing off of my chest. So that was a good thing to do.
Can you
Yeah.
can you maybe add some notes to, I don't know what maybe a good place to put this would be, but maybe the master's timeline as a note in there.
Okay.
About, if you're going to be doing human subjects research, get this training, here's a couple links to like, would that be?
Yeah, sure.
Thanks.
I can do that. Okay, so yeah, so that was it from my side this week. And this is the I have some big goals next week and maybe next week and the week after that as well. So I will be just like I use I forgot the color map. That was Inferno. Yeah, I use the Inferno color map in here. So maybe try out with the Iron Bow color map, like how that looks like. And also I'd love to explore the raster data for surface temperature from the National Weather Service. I did talk with Shakira yesterday. And
Okay.
yeah, so she was mentioning about the NetCDF data. Those are not raster, but I was exploring National Weather Service data. I found some raster, but the problem is I found the JPG images. So maybe there are something. I found one FTP site which has some satellite data. So maybe look into that and try to figure out whether they're usable or not. Or
the net CDFs are probably what you want.
Okay.
And you can it's basically like a stacked
Yes.
raster. So you just need to pull out the one that you need. Arc has tools to do that, and I'm sure Python does too.
I guess in the last semester, Bill also taught us how to work with the NetCDF data. So
Okay.
I will just pull that out and
Great.
work with it.
Okay.
So yeah, I can try that. And also Dr. Miguel suggested me to add some literature from Monmonia and Hungarian Fabricant. So I'll add that in the literature. And also Dr. Miguel mentioned me to write the objective part and
Abstract.
the abstract part, maybe at least something in there, so that it's workable. So I'll do that. And the main thing I need to do next week is outline the whole study, because we need to figure out the whole method and what we want out of the study. So I'll work on that, and also figure out which visualization types I want to be evaluated in the perception study. That's kind of important because we have now high resolution 2D image, low resolution 2D image, high resolution 3D, And we don't have any low resolution 3D, but we have high resolution 3D, and also whether we want to like use other visualization methods, like whether we want to use VR or whether we want to do a 3D printing and project through the projector the thermal layer on it or not. So kind of have to figure out. It's also part of the outline study, but I just kept it in a separate point because it requires some extensive time in it. So yeah, that's kind of it. And also like I'll add some points like talk with Theo about that, and also like make some time for like Dr. Rijal and maybe Dr. Yangsha to evaluate whether my satellite images are correct or not. So lots of tasks for next week.
It occurs to me that you should probably take a look at the like the data before you turn it into thermal data, like the radiometric data, and just see if that has the same pattern. And if it does, then you know that it's nothing that you're doing, right? If the patterns change, like all you're doing is sort of rescaling it, right? You're turning like how much radiation you got back on that channel to like an actual temperature value.
Okay, yeah.
But if you look at sort of the values before you start messing with it, then you'll see if that pattern is changing. And if it does change, then you know that you've done something in the calculations. If it doesn't change, then you know that it's inherent in the data, and then that's a different problem. Like, why does that pattern happen?
Yeah, that makes sense.
Yes.
Okay, yeah. So that was it from my side.
Okay. Thanks, Kenji. Abson?
Sure. Still share it.
Yep.
And then, all right, so relatively, I guess, slow-ish week this week. So taking a look at some of the POSIX space maps, and then got to kind of look at the Velodyne LiDAR unit, which I thought was really cool. And then also just making some improvements to the lab with me. So first with POSIX, there's 2 new anchors. So we now have 6 anchors, and there's up to 8 supported.
I did not know 8 was the max.
So I wasn't sure because there's a couple spaces where it looks like you could have an infinite amount, but it looks like with the creator system, which is the one that we have, there's a creator system and an enterprise system. And the enterprise system is like bigger and definitely way more expensive.
Definitely way more expensive. Can it do more anchors?
I think you can have an unlimited amount of anchors.
Unlimited amount of anchors. Okay, because that was an issue that we had when we were making the proposal over the summer. I was like, I think we should get the enterprise system. And then one of the guys was like, well, what's the difference between that and the cheaper creator? And we're like, I'm not sure. So this seems to be a real answer, is that the
Yes.
number of anchors is
Enterprise,
limited.
I think the anchors are weatherproof, or at least designed to be better weatherproof than I think these ones are. And then there's an unlimited amount. I think they have like a slightly like larger range per anchor.
Okay.
So there's now 6 of them, and I updated and added them into the database, but I haven't actually tagged the coordinate systems yet. So like you can see right here, these ones are currently offline because they aren't plugged in, and then these are the 2 new ones. So the 683B and the 686C.
I know we just bought them, but how much do they cost again? Like 175?
175 per anchor.
Maybe we just went all 8. How far? Okay, so I think, well, I don't want to interrupt your story. There you go.
Go ahead.
My question is going to be, I think the next phase of this is like, how big can we get? And that's,
The creator system is supposed to support a range of up to 1,000 square meters, which would be 33 by 33 meters, which I feel like it could go probably a little bit bigger than that. And next week I'm going to test it out in the atrium, probably on the first floor.
you could use these things outside, right?
Theoretically,
Okay, here's the use case. I've got a friend of mine that's an archaeologist. He runs ground penetrating radar, and he's been wanting to use RTK GPS to do this, which is fine. It does work. But his concern has been, I think it's going to end up being more work to do this, but his concern has been he hasn't found it to be 100% reliable. And like he's often working in places with trees, and so like the GPS signal degrades, And like, he's got to be really precise about where these things go. Like, it has to be within inches, like real 5 centimeter, 10 centimeter accuracy. Like he needs it dialed in that high. And so he ends up doing everything manually, right? He like archaeologists do this. They like lay out a grid and it's very precise, and they go in and they like just manually make everything work. So his experience with the RTK GPS systems has been they're not quite reliable enough for what he needs to do. But I wonder if the POSIX system, if deployed outdoors, would, you know, like what if he set up like a ring of these things around his study area, auto tunes it.
I think theoretically that would work without issues, as long as, I'll have to look into like the weatherproofness of them. 'cause, like,
Well,
if they
I
get
think-
rained on and they all get ruined or like.
Yeah, I think we could assume that it's a nice day,
Yeah.
just for, but that would make for an interesting experiment. I mean, they're mobile. We're probably going to figure out how to do them battery operated at some point. Let's see if we get there. Like,
Sure.
you know,
Yeah.
we could
let's see.
potentially put one of these on, you know, take the rover, which has RTK on it already, have it set to run a very precise RTK path, and then put one of the POSIX tags on it and like compare them, right? And just see how well they overlay. It would make for a really interesting.
Yeah, definitely.
All right, sorry to interrupt, but
You're all good. I feel
that's
like
what lab meetings are about.
Yeah, exactly. Theoretically, that would be possible, as far as I know.
Okay,
Cool. So base map, because I was talking about this a little bit last week. And this big text here is from a screenshot from last week's lab report where when I was using the floor plans as the new base map, some of the spots which were, when I did the calibration with the anchors in the graduate student room right here, they didn't quite match up on the wall as well as I thought they would have. Just because it felt like they calibrated well and they're close enough to communicate with each other pretty well, and they had a pretty strong signal between each other. So I was surprised that when I calibrated them, they didn't fit perfectly onto the walls and stuff. So I wasn't sure if that was a calibration issue or if it was just an accuracy issue in the floor plan itself. So this week I switched back to the GeoSlam, and you can tell there's a really big difference between these two. And I haven't changed the coordinates of these anchors at all. So when I set the base map, basically what I'm doing is I'm setting 2 points on the map that correlate with 2 of the anchors. So when I was setting the floor plan, I said right here is going to be right there, and right here is about right here. And then essentially what it does is it just scales the image to that size. So then with the floor plan, there was an issue where, you know, this is supposed to be on this wall right here, and this is actually more of like right here. So a couple things where I was like, it was surprising to me that it was off by, I mean, this would be probably a couple meters. It's probably 5 to 6 feet, I would say. So then when I added the GeoSlam and I calibrated that, didn't change the anchor coordinates at all. It just rescaled the image. And the shape of the rooms are slightly different between these two. But you can see that this is in its correct spot and this is in its correct spot, with these two being a little bit more accurate. So I think that,
it almost looks like this wall didn't get built the way it was supposed to. Like,
Yeah.
look at that cutout here versus this cutout.
I guess there is, like, it's an old floor plan.
that's the most updated one. That's 2019. That's the newest one I've got.
But that could be one of those things where when they ended up building it,
It
like
just ended up being a little
it
different.
ended up being a little different. Yeah.
Maybe a few
And
things
also
or
like
two.
the gap over here, it doesn't resemble with the gap in reality. Like
Which
the
gap?
This one?
this gap.
Yeah.
Because if you look into that well, the GeoSlam one looks more accurate. See that bit over there?
Oh, yeah.
Yeah.
So
Yeah, it's definitely not like the
This-
floor plan one.
This versus this is a big difference.
All right, well, that's,
Floor plan is not quite as true to design as we thought maybe it was, because this is the most updated one that I've gotten my hands on. Maybe I'll try one of the old ones and see if that ends up being better.
no,
than
I
these things.
think that this is probably right.
Yeah.
My guess is when they were doing the renovation,
Mhm.
something changed for
Yeah.
some reason, and they just didn't get reflected in the.
in construction, it happens all the time.
And it's also possible that like a newer update that this will be more like this, but
Well, that, it is good to know because those things should be pretty minor, right? Like that's not a systematic error. That's like,
Mhm.
we put this wall somewhere else there.
yeah.
So that means they both should be usable. But you'd have to attend to like, if you put the anchors, if you mark the anchors, you'd have to mark them on a stable feature that is correct. And so you could kind of compare the two and know what are good reference points. Neat.
So it does kind of show that the geoslams are more of a true accuracy test, which makes sense. It's hand-done reconstructed, everything like that. So I just thought that was interesting. Felt like sharing. And then a little bit on the Velodyne LiDAR unit. Here's me taking a picture. The shadow looks like I'm flicking off the LiDAR unit. I'm not doing that. I was showing my friend yesterday because I thought it was really cool. They were like, "Why are you flicking it off?" And I'm like, "I'm not." But this was really cool. I thought the real-time visualization was fun to look at. And I also wanted to see how well it would work if I went outside the window. And from what I could tell, you could see me through the window.
Oh, totally. Yeah.
Um,
We had a dancing time yesterday.
yeah. And then just a couple lab wiki improvements. So updating the POSIX page.
Oh, very nice.
Gonna make a page for the tags as well. So probably finish, not finish, but get it up to date by the end of next week, hopefully. And then also I was working on kind of updating and formatting some of the Hexudrone wiki page as well. Just like adding names to the links and things.
Nice. Cool.
So goals for next week are do the building exterior scan, and then I also want to look into doing the interior scan with the Velodyne LiDAR. Setting POSIX up in the atrium and really seeing how far I can push the spatial limits of it, and then continue working with the Hexudrone and continue working on the lab wiki pages. That's all I got. Stop share for now.
Right.
I guess that
Turn it over to the remote crew.
I'm able to share or whatever.
So who wants to go first on the remote side? Johanna, would you mind going? I'm interested in hearing how the stuff went. You guys are all on mute, by the way. If anyone was volunteering.
Sorry about that. I was responding, but
Oh.
all right, let me pull it up. I was adding some stuff since your presentation just because I was curious about stuff. So here we go.
Well, I gotta enable screen sharing on the remote side.
Okay.
There we go.
Oops, did I add the wrong one? Okay. Let me pull that. Can you see a PowerPoint slide?
Yep.
Okay, great. Oh, wrong one. You're seeing the wrong. There we go. All right. Okay, so basically this week I just worked on, Andrea and I went out on Sunday to the Brush Mountain area to look at, to like test out protocols, see if I know how to do everything, how to take down the data, try a few other things out. So we went out on Halloween. So in all the folders, it's called like Halloween data collection. Okay, so when we went out there, when we turned on the RS2 and the M2, we couldn't get it to get a fix while we were out there. It looked like all the settings were right. It was communicating with Neilreach, but we turned it on in the forest. So this is like a pretty densely forested area near Rising Silo or Heritage Park area. But it could only keep a fix for about 1 minute before dropping to float again. And we waited for quite a while. We spent, we didn't get as much data collection done out there as we wanted to, just because we kept waiting for it to secure a fix, but it didn't. So we just ended up collecting in float. We got 2 GCPs that did finally collect in 6, but 6 of them were just float GCPs. And maybe we thought if we might like turn it on at the trailhead away from tree coverage and then walk in, it might work better. I might try that again before we head out. But only 1% of our M2 data was a fix as well. So when I went to use Dr. Pringle's code and tag our images with RTK data, it kept coming back with like the same GPS point for every single point. I couldn't figure out why. So I turned it in, I tried like looking at the PPK and I was like, this doesn't even look like our data collection. Where is everything? What the hell's happening? I spent like an hour on this. It was so annoying. And then I realized that I downloaded the wrong date. This is like October 28th. We were out there on the 31st. So I don't even know how it was tagging images. But it somehow did. Anyways, once I got the correct file, it did look a lot better. I mean, all the GPS points were different, but obviously this is a little bit terrible. This is the general path that we were walking. It was like this straight line and then like a little hook at the end. Yeah, almost all of our points were float points. And I PPK'd it just to sort of look at it because I wasn't entirely sure how to look at the LLH file, like if I wanted to just look at it.
You could drag that into MLib Studio.
Oh, okay.
Yep.
And look at it there. All right, well, good to know for the future. But yeah, it didn't look great, but it actually ended up working okay. So I also used this code here. I used the LLH file, did it for all the images and had it spit out as that image name there. I wasn't quite sure what to do with the time delta. I had a which is why I kind of asked about that, Dr. Pinglo, because I pulled this image out as y'all were presenting, but the GCPs are like really far off from the actual, like, so this would be the RTK data. And this is the ground control points. They're like,
they all seem a little shifted in that direction.
yeah, and then, so I was just trying to make a quick, I was looking at the EXIF data of the photos versus, and I started doing this as well. It's like 20 seconds off. The GoPro time, yeah, 20. The GoPro time and the time that is from the cell phone. So this is like 10 minutes, 44 seconds, whatever. So they're about 20 seconds off.
Okay. Well, and did you look at so when you look at the EXIF data, you'll want to specifically, so one thing to look at is the time. But if you look at, I don't know if it'll show, did you just look at it on the properties? Oh, there you go. Nice. Okay. Good. So if you scroll down, there should be like a GPS time as well. So
Yeah,
so
this has sub-seconds here. Yeah, so it's 3:10:41 sub-seconds, 5610.
Okay. Keep going down a little bit.
GPS time was even weirder. Where is it? Flat long L timestamp, because it has it as like not even 3 o'clock. It's like, was it 7 o'clock?
Yeah, so that would be the 4 hours ahead from the time difference.
Got it. Okay.
But the minutes and the seconds should be.
Yeah, that is.
Yeah,
That is way better. Where do you get? Would I use the sub-seconds from the other one then?
I don't think that's reliable.
Okay.
I think I thought about that, but I think that's a gamble. Last week I had figured out that the sub-seconds wander a lot. So I don't think that I don't know what's going on in the GoPro code. But anyway, so that's 22. And then.
Yeah, that looks a lot better so that would be this one. Okay.
And then the time that is, yeah, that's right.
Yeah. Okay. So great. I guess that solves that mystery for me.
The local time, if you connect to a GoPro with like the app, there's a button that will be set date and time, and then that will set it to whatever your phone's time is, which is going to be correct to within a second usually.
Okay.
So that's a nice thing to do before you go. I don't know that it makes a huge difference because the sub-seconds are unreliable anyway, but at least then it's like aligned to within a second or two.
Yeah. Okay. Cool.
I kind of
Thank you.
have a silly question.
Yeah.
So I'm still not clear why we are using the time thing. And like what's the purpose of it?
We're using the time thing because we've got two separate records that we need to join. We've got the camera, which has a GPS, but which is not a good GPS. And we have the RTK GPS, which has a very precise location. And we need to tie when this image was taken to where you were when that image was taken.
Oh.
And the way that we do that is by having the time, by comparing the timestamps. But we've got the time, the time has to be very precise. If you're traveling 1 meter per second, then if you are off by half a second, then you're off by half a meter. So you need to get it dialed in pretty well. I mean, ideally, we're trying to get these dialed in to like within 5 centimeters. So that means getting it correct to within 1/20th of a second. So that's why everything has to be sort of like very precise.
Okay. Thank you.
Yep.
Yeah, so the general, I did this with I got this done with one run this week, but I did 4 different runs in Pix4D, raw, with RTK, with GCP, and with both, just to try to compare. So this is RTK, no GCP, no GCPs, and it did improve the, before and after. I'm not really sure it actually made much of a difference besides just orienting the entire cloud and maybe putting it in the general right vicinity of stuff. Oops, this totally didn't. Let me fix this here. If we can see it super well, but the geolocation error is way better with RTK, so that's nice. And our average point density for this run was 333,000 points per meter cubed. That's also, super high. This is what the point. So basically out here we have these permanent transects set up. So we know the exact measurements from this line all the way down to the ground, and I wanted to try to see if I could see the tape measure from nail to rebar, and we can, so that's really cool. Oops, why does that do that? Sorry. There we go. And we can see it, so that was exciting. I also clipped out the cross section. Also looks pretty great. I haven't had a chance to, I'm trying to figure out right now how to actually take these measurements. So we took measurements every 10 centimeters along this line, and we got the general base. Basically, we have this, well, we can get like, area underline for points on this curve here. I'm currently trying to figure out how to, automate that so I can get, compare all of these clouds and kind of see how consistent these runs are, which would be really interesting, I think.
So when you go out into the field and you do these measurements, you take that straight line, the string or whatever it is, and then you measure down
to the ground. Yes.
Yeah. And you do that a bunch of times.
Every 10 centimeters along this line.
And then you use like the area of the trapezoids of all of the connections.
Yep.
Huh.
To get like the volume measurement of that right there. But we could also just compare, you know, width from stake to nail and other things, I guess. But I guess like probably the most equal comparison would be that volumetric area.
So if you wanted to do this in like GIS, you could just bring this in and then like swap the Z and the X coordinates or something to like flatten it out. And then you could just like trace a polygon, and then you probably could just do this. Actually, I bet Cloud Compare has a tool for that, right? Like, can Cloud Compare just do that?
Yeah, I think it does. I tried using it and it had some kind of problem with, I haven't quite had enough time to explore it. It had some kind of problem with the gaps in it. I don't know.
Anyway, how encouraged, I mean, I don't know what I'm doing. This looks really good to me. Does it look good to you?
Absolutely. I was really excited about that.
Great.
Damn it, why are these images not? Okay, so this is what GCP with RT or no RTK, it had problems with my GCPs, basically huge amount of error, RMS error of like 2.0, 2 meters about. And as you can see here, they're just way off the GPS line of the GoPro and the RTK, even though this is no RTK here. So yeah, huge amounts of RMS error with my ground control points, and even more so with geolocation error. Like it's worse than with so just RTK alone was much better than with GCPs.
Huh. Yeah, that kind of mirrors the experience we had. So this is, again, I want to clarify. This is RTK with GCPs, and it was worse.
This is GCPs, no RTK.
GCP. Oh, okay.
Yeah.
Gotcha. All right.
Yeah. GCP. There we go.
Got it. Okay.
Yeah, worse than just RTK.
Okay.
And I ended up with, yeah, we seemed to have some ghosting going on basically, whereas there wasn't with just RTK.
Okay.
Then I just like overlaid the clouds together basically. Maybe this would make more sense here. So RTK, no, it's so confusing. Basically good reconstruction with RTK, no GCPs, but like this has better reconstruction, but it seems like it's not quite oriented right. Like they're a little bit off. So it seems like with the ground control points, it like snaps it to the right place, but with ground control points itself, we have ghosting.
Okay.
Okay, so now I did all of them together, GCP and RTK, and this was by far like it's weird. So we have like maybe better than just GCPs themselves, but worse than just RTKs themselves, with RMS error with ground control points and just general geolocation variance. Not great here as well, but looks a lot better. The point cloud itself looks a lot better, and we don't have ghosting here anymore as well. So also, if we overlay the RTK and GCP and just GCP, no RTK, the point clouds are almost identical. Like besides they're like so close on top of each other. So that it does seem like the GCPs like puts it generally in the right place, but there's just the ghosting errors with just GCPs. And so
What's the difference
conclusion,
between strings like like on slide 23? How far apart are those two strings? I mean, I know it's one string in reality, but the ghost strings,
the ghost strings, I don't know. Sorry.
like a couple of centimeters?
Probably inches.
A couple of inches, okay.
Yeah.
Okay.
Yeah. So, conclusion, I guess, RTK and GCP both together seems like the best of the reconstructions. For some reason, just GCPs alone don't do great.
Yeah,
Well-
I would love to see a plot of like the onboard, the GoPro's onboard GPS against the RTK points for those images.
So here's that. I think so. This is
That's the regular GPS points straight from
Yeah.
the GoPro, and that's the RTK.
yep.
Yeah, I mean, it's pretty much in line with what we thought, right? Like
Mhm.
the GoPro's GPS is bad,
Mhm.
probably worse under the canopy, so we're getting some benefits. It's good to get a test. My sense, by the way, Johanna, is that
Mhm.
getting a fix before the trailhead is probably only going to benefit you for a little while.
Yeah.
And then once it starts to get off, then it's just going to be off again. So
Yeah,
I don't think we knew what to expect with the performance of RTK under a dense canopy like this. So,
Mhm.
and I don't know. I mean, have you seen anything about RTK GPS performance in a wooded environment? Do people have a sense of what that's supposed to be like?
No, I haven't actually. Yeah, I don't really know what to think about the GCPs. Like, so the RTK alone by far has the best RMS error, I guess. And like even both together is still worse than RTK alone. So I don't know what
Did
to.
your, I guess I didn't ask this. When you did your GCP collection, did you get some fixes off of that? Like,
We got 2 points with, so only 2 of the GCPs are fixes.
okay, so those by themselves could be bad. And then how many did you do? Like 8 GCPs?
8, yeah.
So those could very well be off.
Yeah, this one and this one are the only 2 with fixes.
Okay.
And honestly, like, yeah, that one is kind of the closest to. They are, yeah. So I don't know. I guess I'm not really sure what to think.
And your study area, no cover, right? So you shouldn't
No
have
cover.
problem at all.
So that's good. Yeah.
This is like
but-
worst case results then, probably.
Yes, I think so. And I think it's still pretty promising. Like if we don't necessarily, I think RTK alone, like I'm really curious. I really want to go and compare all of these measurements to see how consistent they are. Because if they are consistent, which is, I really hope so, then we don't necessarily need it in the exact same place as long as
Yeah.
we have right measurements. Like I'd rather have, yeah, good measurements than.
I want to draw on this slide for just a second.
Yeah.
This.
Oh, sorry. You don't draw on the slide. Go for it.
The kind of white line that's like right here. Is that like a piece of string that's hanging down?
Yeah, so we were using a 50-meter tape measure. We put one end over the rebar and then binder clipped the other end to a nail in the tree. So the rest of the tape measure is basically just hanging down.
Okay. Okay.
Yeah.
What if you just took a photograph of the line? Like, rather than a 3D reconstruction, would you be able to, how good of a job could you do with just a photo of that scene?
I don't know. We have photographs of them, obviously.
Yeah,
With,
you get like distortion from the camera effect, and you wouldn't know quite where the ground was.
exactly. Like if we're not directly looking at that tape measure, I'm not sure if we could like it just might the angle might be slanted slightly, which would change the measurements drastically.
That's right. Yeah.
Mhm.
Okay.
Yep.
Sure.
Would y'all mind if I do like a quick presentation of my own?
That'd be great.
Cool. Go ahead and share my thing. So basically my personal project has been scanning this old warehouse. Well, not a warehouse. It's an old power plant on Belle Isle in Richmond, which is an old Civil War prison island. So I've just been using my Mavic Air 2 because I'm cheap and I don't have funding. But the idea here, so this is the first sort of collection I did where I was trying to get like super granular images of this graffiti on this one wall. I was getting like very, very scattered GPS points for all these photos. Like I was literally just flying them in a straight line along here, but not a single one of these points showed up where it was actually supposed to have. It came out really, really well. Just kidding, I shouldn't have done that. It's gonna zoom me to the other side of the planet, so this isn't worth it anymore. But yeah, the idea is I also went through and did a separate one of the entire building at a much coarser level. And honestly, like it came out pretty well. I did scan all 4 walls, but I think again, so like those really weird placements I was seeing with the image points resulted in the whole thing sort of like being shifted on an axis and it trying to almost turn this 3rd wall into both the 3rd and 4th wall. So I ended up with like a triangle type thing going on here. So yeah, I took this and I moved it into ArcGIS Pro so I could correct all the orientation of the different sections, which ended me up with this in the end here. And I think it came out like really well for a first photogrammetry project. So
Yeah.
like even these little divots in here like came out really, really well. So I'm super happy with that. I'm gonna go back this weekend and try to capture the floor so that I can test like if I use that GNSS app to create like rudimentary GCPs, if I end up with something that's gonna look significantly better. And then ideally fill in some of these patches here, which honestly I think are just due to shadows. So I'm going to peer pressure my friend to go with me at like 9:30 in the morning so that the sun is coming from the opposite angle that it did on my first collection, so I can light up this 4th wall and then hopefully catch some of these corner type things as well. I don't know if I'm going to have time to scan the whole thing again, so I'm going to try and sort of patchwork them together, which I don't really mind because I don't have any need to measure any of this stuff, so I don't have the same stake on accuracy as y'all. But yeah, so basically like the overall objective for this is to completely model this space. And then you can actually crawl through this hole if you're my size and have no sense of self-preservation. And there's a sort of like almost like a pump room on the other side of this where like all the water would come in from the river and then go down below. It's going to be a lot harder to scan in there. There's still graffiti, but not quite as much. And like, honestly, like the reason I scanned it obviously is the graffiti is beautiful, but it provides really great key points for the stitching afterwards. So I'm hoping that I can get some scans in there as well. And then ultimately I'd like to find someone with some sort of game engine experience and create like a virtual reality model or experience out of this place. So yeah, that's kind of my little passion project I have going on. But my coworkers are really loving it because you can literally like look out the windows at the river, which I was surprised the windows constructed at all considering my setup. So
Yeah, that's interesting.
Yeah,
Are
thank
they
you for coming to my
are
TED
they
Talk.
fully transparent windows?
Yeah, most of them don't have, none of them have glass in them anymore. They're all just sort of iron bars, which is honestly like why I really was excited to try doing this place as an indoor collection, because I don't see many indoor photogrammetry projects like strictly based off RGB images. But considering how many huge windows there are in this place, and you can't see them, so this is only like half the height of the actual building. I didn't have the time or battery life to do the second top of the building, but I don't know how well it's going to stitch, just depending on how much variation there is in the walls. But yeah, there's more windows up there, so you get a ton of natural light. If you get the timing right, you just have to, I think I'm going to have to follow this pattern of collecting at 2 different times of day so I can light separate halves of the building. So yeah, we'll see how it goes there. I'm just going to slowly start Frankensteining this together.
Do you have any VR equipment of your own?
I have like a VR headset to just like plop a phone into, so it's nothing too fancy, but I have a feeling I'm gonna take enough time trying to get it together in a game engine that I'll be able to save and invest in some better hardware.
Yeah, I forgot to mention this, but I did end up buying a Oculus Quest 2 for the lab. So we've got 4 VR headsets at this point. I think we've got a 5, we've got an old Oculus, which is not even all that old, and then we've got a Quest, and then the Quest 2 will be coming. So if you want to borrow one, Karen, to just sort of see how it does, let me know.
Cool. Yeah, I'm gonna be gone for like 3 weeks, and then probably we'll see. I might be moving back to Richmond, which in that case, I can slowly collect the entire city and turn it into a 3D model. And host it all on Esri servers, not pay for a cent of it. So that would be the ideal situation. But yeah, no, if I can get it going soon enough, I will absolutely take you up on that.
Does Esri have the ability to do web VR?
I don't know. I expect it's in their future plans. Most of that stuff they do through City Engine. Like that's sort of their technology space for it. I'm not entirely sure how people are using the online scenes yet.
Okay.
That's a good question.
Cool.
Yeah, cool. So
Thanks.
thank you for coming to my TED Talk. At some point I will have more things to show.
Graffiti is like ideal for generating key points. It's like
It really is.
also, like solid, so like it's like just like the perfect level of complexity probably.
Yeah, exactly. I'd like to do some more scanning of so Richmond has a ton of murals. So like same concept, I think it would be fun to do that as a project. If I have the time this weekend, there are also some old bridge supports that have been converted into like outdoor rock climbing locations. So I want to see if I can do some like vertical scans of those as well and see what would generate. I don't know, because I'm worried the same thing, like be too much repeating patterns just as far as the stonework, but I think it might be worth a shot as long as I'm there to see what comes out of it.
Yeah, cool, very nice.
And I gotta hop off and make some calls, but y'all doing great. Bye.
All right, who's up next? I saw in the chat, Johanna, 3 centimeters, you say? Nice. That's not too bad. Chandler, you want to go next?
Sure.
I see you have some models in here.
Yeah, I left those in there because I figured I would be zooming in. Sorry, let me change my tab real quick.
Are they, I'm not going to break anything if I move them, am I?
No. Go ahead. So I wasn't able to present last week, so it's going to be 2, and I'll move quickly just because a lot of slides. But I've been working with a design club here at Tech to kind of generate some architectural visualization, and I've been trying to use LiDAR as part of that. So the goals from last week were to do that. So I took the Cloud Compare scan of that area and broke it down into 3 separate layers because the canopy was like 70 feet tall. So there were multiple types of vegetation in that area. So I broke it down into 3 layers, and as well as a contour map to generate this kind of base map in AutoCAD. So I just uploaded the images, and then I just went through with the CAD tools and just traced out the various areas in order to get that sort of full complete look. The takeaways from that were there were some artistic liberties that needed to be taken because it was a little difficult to tell the tree canopies, as well as using just the various tools. Like I didn't go in and trace every specific tree. As you can see, I just used 2 general tree type images that we have in CAD. So that's that was a little difficult to work around. The contours worked pretty well though, so I'm pretty happy with that, especially because it's a flat site, but you can see up in the distance that there is much more definition. So I think that worked out pretty well. And then I didn't put the shrubs on this map because this is a larger map, you know, that's showing like almost 1,000 feet. So that couldn't really come across. It looked really busy. So my next move is to do a site specific detail plan at 300 total. So, you know, like probably 20 scale at 300 feet total. And then I'll be able to show the shrubs as well as the various trees. And that's what that blue model is showing. This was sort of experimentation with scalar fields, trying to show the overall area as well as the site specific details. I presented with this to, we had like a pre-presentation with a group of architectural professors. The thing that was difficult was that I had that base plan next to this, and as a result, like this was kind of scrunched up, and they weren't a fan of that. They liked the model, but to actually pull some information out of that, they weren't really getting its usage. So I needed to continue to experiment with that. So yeah, this was another slide that I generated, just trying to show like the tree canopy. I did a claw simulation, removed the ground points as well as the mesh just to show the tree canopy. And then I highlighted a specific section in green and showed it on the right. Something that was also
generated. Was this cross section generated in Cloud Compare then?
Yeah.
Okay.
Looks
great.
Thanks. There was actually something interesting that did come out of this, and I'll talk about that later. But something that came about was the idea of orientation when giving a presentation like this, where this image on the left, north is pointing up, but that doesn't come across here, where it's actually north is pointing like towards you. So I think if I were to do this sort of layout again, I would probably have to flip the section, show that north is kind of pointing away from you so that it can line up like, I guess, for example, this orange triangle would need to be on the left instead of the right, because you're kind of looking at the section from this way, and I think it would make more sense if you're looking at it from that way. So that was what I did last week. And then this week I jumped to 3D modeling and creating that model that you see there. So the first thing, I guess I should have had this before. What I actually presented with this week was this slide of Google Earth, just because something I noticed was that with the animation doesn't show up in this slide, man. Something that they wanted to, the professors had me look into was showing the relation between the site and town. And I actually generated a LiDAR animation in Cloud Compare showing that. But something that I was like hesitant about was that it didn't have that photorealistic coloring or data. So I ended up just using the Google Earth. And then I went back through your lectures to see which kind of LAS tools I could use in order to kind of put that ortho photo onto the LiDAR model. So I'm gonna use LAS color this week in order to do that. I also did some more literature review on how to do that, and I found this really awesome landscape architect who actually is editing point cloud model scans that he makes and putting his designs into that. And he wrote this whole doctoral thesis on it. This is the QR scan to take you to it, but I can also just kind of share it with you. Second. Let me just exit this. So this is the scan. It's a town in Singapore, and he edited it so that this is the landscape design, and it can be viewed in VR. And I think it actually is really good at showing that visualization. This is kind of what I've been trying to get to. So I've been reading the thesis, and I'm gonna see his actual process for doing that.
That's great. That's something that I'm not very familiar with. Is sort of like, I mean, I can sort of think of how I would do that, but I'd love to see somebody that's really ironed that out. So I'll be very curious.
I'm gonna take a bunch of notes on it, see the whole process for that.
When do you graduate, by the way, Chandler?
Next year, next spring.
Next spring. Okay. I got somebody that might be interested in your skills that you've been developing. You mind if I pass your name along?
Yeah, sure. This is the process that I've been working through for the 3D modeling. So at Kogel and Burchard, we have a plastic shop where you can 3D print as well as edit plastic materials. So I did a print. I actually had a funny thing happen where I was trying to make this print in white the first time, but I didn't realize how low I was on the filament because these prints actually take a lot of filament. So it ran out halfway, but it presented me the opportunity to see about printing with just the, or like putting trees in with the infill. So I did this with 10% infill, and it actually fits the tree pretty well. I just used some tacky glue, and like the issue was that the detailed layers actually hold the tree in place, and the infill just kind of provides that like little extra bit of support, but to just have it by itself, it doesn't really work. But outside of that, I printed a little cube. I just printed the default cube in Blender and then tested some various drill heads, which you can see right here. The most successful one was 5/32. So I just drilled that in various places on the model and then placed the trees with no glue, because then you're able to swap in and out with the trees. But this model actually benefited me because when I went to the community meeting and presented this, one of the community members noted that there was under canopy, and I was like, what are you talking about? Because I went on a site visit and the trees were 70 feet tall and there was no 30 to 40 foot trees that I saw on the site. He's like, that's because they were removed. And I was like, okay, so when you look back on this model and there are trees in the middle canopy right here, this whole layer of trees was removed in the past few years, which created additional flooding, which is why that's such an issue for the park now. So I was like kind of blown away by that. So through this process of editing point clouds, like I was talking about the landscape model, I'm going to see if I can remove some of that lower canopy to show that before and after, because part of my proposal moving forward is to introduce new plantings, new trees. So I will show that in the before and after, just have the higher canopy and then the new lower canopy in the after model with the full design. I'm also going to have to remove a lot of this lower vegetation from these trees, just showing them kind of like with a canopy at the top. So I talked to one of the professors that was in that pre-group with us, and he said for the final presentation, just kind of invest like $50 into total material for the model. So I'm going to set that as my budget when I'm creating this final 3D model. So the goals I have for this week.
Have you found anything for 3D printing? Is like Thingiverse have 3D printed like models of trees? Like instead of buying, like you bought these trees, right?
They were just general resources from the landscape department. Like they had a few bags of them, so I just used those.
Could they be printed? And
they can be printed. that is something that I've been looking into where what sort of, I think I'm going to do a notebook on it. What I was planning on doing is taking 2 images from the LiDAR scan, sort of like showing the X and Y axis. And then I can use a blender tool to trace a polyline and trace the branches, use a modifier to give it thickness, and then export it as a STL, which I can then print.
Okay.
So I'm going to try that. And then I'm just going to use some like brambles similar to those trees and just kind of, you know, put the leaves on there.
I guess I was like, that sounds awesome, and I would love to see that. I was thinking, like, I wondered if like Thingiverse had any models that like you could just like download, and you know, maybe there's a variety.
Yes.
And then the nice thing about that,
Yeah, there's this thing available. In Google SketchUp, there's this big library of like objects. So you can find plenty of trees, like variation of trees in there, and you can just like export it into STL and then you can print it.
okay.
Yeah, Google SketchUp has like really extensive libraries for that.
One of the nice things about that was then you have the ability to scale the trees
Yeah.
relatively precisely to the size of the scene that you're doing. You could really dial them in pretty perfectly.
I found this sapling generator for Blender, which basically just kind of like generates an STL, and you can like do the specifications. So I tried to do that with the Blender base map thing that I developed, that I was the project workflow. I copied that and did it for the site, using like the Blender GIS thing that I talked about like at the beginning of the semester. I tried to do the sapling generator for that. And I was having a little bit of issue with just the Google Earth image, because it was a little hard to tell like what was tree and what was ground, because it was wintertime. So the trees, you know, I was just going off the shadows. So it was a little difficult. I'm gonna keep working with it, and I'll talk about it if I get anywhere with it. But yeah, I also wanted to try. I know you mentioned that Cloud Compare has VR capabilities, so I guess like that's one of my goals to see. Do you know if Goose is still like having problems with the Oculus? Or
You know, I met with Miranda last week, and we had troubles with it, but I think I figured it out. I think it was, I guess the new Quests have an Air Link, which lets you do the link to a PC and run all those apps, but without the need for a cord. So I think I'm trying to do that while I was trying. Anyway, I think I got it figured out. I haven't tried it today, but I got it working on my laptop in my office, which was having the same problem. So we'll bring it in and see.
Sounds good.
A note on Last Color. So Last Color is probably licensed, and I don't know what it's going to do if, you know, the same Last Tools problems we've been having. Like I don't know what it'll say about the license expired. It may work just fine, or it may not.
Yeah.
But ArcGIS also has a version of that.
Oh,
I can't remember the name of the tool, but it works exactly the same way.
okay. I will look into that, because I definitely want to. I just want to project a photo onto the data so that it colors it so that it looks correct.
It does look good. I think it's the state of Connecticut has like a whole like colored point cloud, and they talk about like the importance of that. And if you're interested in they've got like a web version of it. So Google like colorized LiDAR Connecticut, and you might be interested in poking around with that for 10 minutes or something.
I got to Last Color because I found a study, like I found a practicing landscape architect that was doing it. So then I went back to your lectures and like saw that you had also said Last Color. So I was like,
Yeah. Last Color is great. It's just one of the like I don't know what's gonna happen. There's something else with that. In Cloud Compare, have you figured out how to bring in like an orthophoto if you wanted to use that as a base map in Cloud Compare?
yeah, I tried to do that, and I downloaded the orthophoto data from the Virginia Clearhouse, and I wasn't sure what could read it. It said it's like a SID file or something.
Yeah. So it's a format called Mr. SID. It's a really dense image archiving format. ArcGIS can read it. So if you look in the lab archives, I think I talked about it from a presentation from a couple of years ago. So you can look at it there. And then, but generally what you'll probably want to do is bring it into ArcGIS and then clip out the section that you want and then export it to like a TIFF or something, or a JPEG or something, and then just bring it in that way. But Cloud Compare can read in rasters. I mean, probably what you would want to see with an orthophoto would be like an orthophoto draped over like a DEM surface. I think would probably make for a pretty good layer. So see if you can figure that out, but if you can't, let me know and I'll try to give you some pointers. I'm not sure what we covered. Did you talk about that in GeoViz? Maybe not.
I remember briefly learning a little bit about the Mr. Zip files. I don't remember what.
But did we ever create any like draped, when we did draped images on terrain, we did it in ArcScene, right?
Yes.
And those are not exportable as far as I know. So we may have to figure something out with a good way to do that. Anyway, poke around a little bit, Chandler, but if you can't figure it out, come talk to me.
Sounds good.
Cool. Well, this is really impressive. It's nice to see physical models. They're always fun. All right, we got Barrett and Colleen next, I guess.
Yeah. Oh, sorry, I can go.
Okay.
Let me share screen. Uh,
Yeah, thanks, Johanna. I am not using it, and I'm supportive of rebooting them.
Okay. Anyone else? Can I reboot Maverick?
No, that's fine. Yeah, I logged out as well.
Okay, cool.
Oh wow, my computer's slow today. All right. Okay. Everyone see all right? Is this Zoom thing in the way on y'all's screen too? Just
Usually
move
in
that.
our lower right-hand corner, it's okay for us.
Yeah. Okay. Cool. All right. So I did a couple things this week. Minor point was when we did the exterior scan of Wallace last Friday, we had problems capturing the windows. So earlier this week, I was trying to figure out information on how to better that process. There isn't too much. A lot of the fixes that people have are like for really small scale stuff, like a glass bowl, you can like spray it with like matte spray. Obviously that doesn't work if you're doing a whole building and everything. One thing that we did find was people mentioned that a polarizing filter can help because it reduces the like reflection from the glass. And GoPro actually has like a little $16 polarizing filter you can stick on the end of the camera. So I think we're ordering that, and it'll be fun to test out, run a small scale, easy experiment to see if there's any benefits or difference between using the filter and not. So with Wong Park models, we're getting towards the end of them. And as the route has increased, we're seeing more and more problems. Route 6 isn't too bad. You can see it's kind of just like the GPS might just be a little off, but the PIX corrected it pretty well. And then Route 7 gets a lot worse. It's like very noticeable from far away, ghosting and just splits and all sorts of stuff. Then we hit, I didn't realize I put this in here. Yeah, this is another Route 7, it's pretty messed up. And then Route 8 just didn't run at all, which is the first time I've seen this happen from the models that I've ran. We talked about this a little bit on Wednesday. We're not sure why it could be happening. Could be that this route was scanned with the camera like attached to a backpack or a shoulder strap instead of carrying it around the normal way. Regardless, we think the camera angle might just be kind of messed up, because if you see like right here on the right, this picture, there's a lot of person in it. So maybe that's the reason that this got messed up. We're not totally sure after looking at the metadata. wasn't too much to go off of. So still trying to figure out why it is that these ones are messed up. For the indoor photogrammetry thing, I tried to merge Wallace and with the LiDAR and the GeoSlam. So this was the initial merge. The blue right here is the LiDAR, the ceiling and roof, and then the red is the GeoSlam. So I thought this was an abysmal failure, but actually, like all things considered, this is pretty close, a lot closer than like it could have been. So then after this, once we got it this far away, we went ahead and started like manually moving it. And so this isn't the best picture, but if you can kind of see, the green is the GeoSlam and the white and black is the LiDAR. So I played around with it for a while and I think I got it pretty close. Like this lines up pretty well. I think, I forget what I'm supposed to do with this now. I guess, because we need to try and figure out if we can get the coordinates so that this will set up automatically. But
What state is it in now? Is this like loaded on Goose somewhere in Cloud Compare?
yeah, I saved this as its own file in Goose.
Okay.
It should be called it's something merged, something like that. But I made sure to name it specifically because I know there's another file named merged in there. But yeah, it's in the same place where the SLAM and the LiDAR are. So
Is this still open in a window that you have?
I don't think so, no.
Okay.
Do
Hopefully,
you want me to, I can pull it up.
that's all right. We can maybe do it after the meeting. I don't want to take too much time, but
Okay.
I am, so like one of the things is, so like the GeoSlam was never
Reference.
geo
Yeah.
part is a bit of a misnomer. It was never geocoded, so it was just in sort of an arbitrary coordinate space. You have now successfully got it into a geo, but I don't know when you save it if it would then attach the geo points to it or not. So we'll have to look into that. But maybe after the meeting, can you hang on? Do you have time to hang on the line for 10
Yeah.
minutes so we can take a look at it?
Yeah. One possible problem is I moved the LiDAR. So I don't know if that would mess it all up.
You moved the LiDAR.
I
Yeah,
moved the
that might
LiDAR.
mess it up.
So yeah, well, even if that totally messed it up, I figured out like at least I kind of got a handle on how to do it,
Yeah,
so I can redo it. I ended up not really getting I remember when we were trying to, like you were explaining this on Wednesday, we had a hard time getting the translation rotation tool to move, and I still couldn't get it to move. So I pretty much did all of this manually, just typing in numbers in the thing, and just eventually finally got it. But
Okay.
yeah. But yeah, I'm pretty happy with how it turned out. Even if it doesn't end up working, it looks really nice.
It does
So,
look nice. Nice work.
Pretty good progress on that front.
It's a neat visualization too, like the color and the, I don't know. I know we've been doing that a lot this semester, but I always really like it. Like it looks.
Yeah,
really
no,
good.
it looks really cool. And this is like cut out. Like we cut a lot of the SLAM out. It's a small LiDAR thing, but it's pretty cool. For people that didn't see it, this is kind of what the base LiDAR looks like on its own. So this part right here is the roof, and then this is the surrounding area. To make it easier for myself to see, to match it up, I increased the point size by like 4 times. And that was quite helpful. That's why it looks a little bit different. So the big thing coming up, number one goal is the exterior full scan of Wallace. So to do that, we're gonna have Andrea help us because she knows how to compute the GCPs. Got to plan the walking path just to make sure, especially on like the left side of the building. But we should be able to get the whole scan probably in like 20 minutes, maybe. I don't know how long GCP calibration takes, but shouldn't be too hard. And that will be the big fun thing. We can see how that goes. And then when something goes wrong, adjust for that. I also tried to 3D print yesterday, but my 3D print failed, unfortunately. So I've had my first print fail. And also, I feel like I'm forgetting stuff here, but I also wrote down to try and look more into the Wallace or Wong Park model and see why it is that it's not failing, or it is failing in the later routes.
Sounds great.
Alrighty.
Thanks, Barrett. Colleen, how's the writing coming?
It's coming along pretty good. I found a couple of things, a couple of articles that talk about the DEMs I'm using, so I'm gonna try to incorporate those into my thesis today.
Sounds very
I
good.
also found like my very first maps, which is really weird to look at because it was like 6 years ago.
Found them like the first ones you made for like a GIS class?
Yeah, my senior year of high school, I took one because it was a dual enrollment program through JMU. So I like found maps from my senior year of high school and it was just weird to look at them.
What did you think?
I definitely can see where I need improvements. I mean, I have one up on my computer. I don't know if you guys want to see it or not, but
We do.
Yeah, I definitely want to see that.
all right. So this is one of the first ones that I made a while ago. There's so much white space on it.
Wow. The Colleen Lewis, Virginia highways.
Yeah, it was an assignment for the class.
This is
But I've
this is
come a
pretty
very
sick.
long way.
Yeah. It's always good to kind of look back and see where you've been.
Yeah.
I like
Yeah.
the inset map.
What
Like
was
with
that?
I like the inset with Virginia highlighted on the US.
Oh, thank you. Yeah, that was one of our first lessons was how to do inset maps.
Wait, so when did you do this? It was a dual enrollment class in high school?
Yeah, so 2015.
Oh man, I wish I
2014.
was doing this stuff like way back then so I could pull up something like this and be like, dang.
Yeah, this was also an Arc map, so it was in the desktop, not not Arc Pro. And then this is what I made for the summer, which I mean, I'm not a huge fan of the photo I had, but that's all I had at my internship. So, I mean, less white space. Oh, this one had too much information on it. This was the very first one I made. So, yeah.
Cool. Fun. Yeah, I've saved, I don't know what you guys do when you save your assignments and stuff, but I've still got stuff that I did from college. Like, it's fun.
Yeah.
Back at that stuff. Awesome. Well, thanks everybody. Good meeting today. Everybody's making a lot of progress, so that's exciting. Did you have any questions? I mean, you're still kind of fly on the wall mode, but at some point.
I like it. I like just to like kind of get a feel for everything. So.
Yeah, absolutely. All right. Well, thanks everybody. Have a good weekend.
Bye.
Barry,
everybody.
you gonna hang on the line for just a second and see. if
Yeah. Yeah, I'm gonna hang on the line. I hope my laptop can survive another round of cloud compare. Been putting this poor baby through the ringer.